does that special rule for dividing fractions come from? Let's take a first look where we have a fraction divided by a fraction and they're contained in another fraction. So a divided by b as the numerator and c divided by d as the denominator. Now a divided by b numerator is the same as a times 1 over b. And the denominator, c divided by d, is the same as c times 1 over d. Now to get rid of that over d in the denominator, we're going to multiply both our whole numerator and whole denominator by the letter d. This is because 1 over d times d is equal to 1. Any number divided by itself is 1 as long as that number is not 0. That gives us a new numerator of a times d times 1 over b all over the denominator c. Now to make this denominator go away, we're going to multiply it by 1 over c, both the numerator and denominator. The same is applying here where c times 1 over c is equal to 1 as long as it's not 0. This way what we can get is a times d times 1 over b times 1 over c, which when we simplify we get AD all divided by BC. And this should be thoroughly confusing for a lot of people at this point. What about, instead of writing it as a fraction, we write it as a division problem? So A over B divided by C over D. I'm just going to expand this out and leaving a little bit of space to put A over B and a gap, my division symbol, C over D, and I'm leaving another space. Now I'm going to multiply my entire first term by the denominator, so d over d. And I'm going to multiply my entire second term by the denominator of the original first term, or b over b. This way, when I multiply them, I get a times d divided by c times b, all as the numerator, over b times d divided by b times d. At this point, I can see that b times d divided by b times d, that's 1. That'll work in any case as long as they're not 0. So when I simplify, I'm left with a times d all over c times b. Still confused? Let's try it a third way. Going back to a fraction over a fraction. Here I'm going to multiply both the numerator and the denominator by the inverse of the denominator. So my denominator has been c over d. I'm going to multiply it, both the numerator and denominator, by d over c. This is going to give me a times d over b times c, all divided by c times d divided by c times d. My denominator is a number dividing itself, which is 1, as long as those numbers are not 0. So my numerator, AD over BC, is what's left, and I've got it simplified. If all else fails, that's when we get to see where that special rule came from. So looking back where it's a fraction dividing a fraction, a over b divided by c over d, I'm going to go ahead and use that rule, the keep, change, flip rule. So we just have a raw application. I'm going to keep a divided by b. I'm going to change my division symbol to a multiplication symbol, and I'm going to flip my second term of c divided by d. This is going to give me a over b times d over c. And I multiply straight across as I do with fractions to get AD over BC.